All right, ladies and gentlemen, I want to say a big welcome to all of you. Welcome to the Valley of the Shadows of Probability Distribution. It's a pleasure to have all of you. So we want to continue with our probability distributions, and we're going to look at the most powerful of all probability distributions, and that is known as the normal probability distribution. Remember, knowledge is the only asset that multiplies and creates all other assets. And until what you know becomes what you do, you don't know anything. And until what you do benefits you and someone else, what you do is useless, because the evidence of knowledge is result. A continuous probability distribution is one where the numbers are decimals. We call them intervals when they are whole numbers. But when they are decimals, they become like a continuous random variable. Now, in such a continuous random variable, the variable assumes any value of an interval in the real line or in a collection of intervals. And that, if you want to find its probability, it is known as the P of x equal to x, while this second small x is actually the number that you want to actually find its probability. So the way you write the probability is that you can talk about the probability of an x assuming a particular value. But instead of talking about that, we can also talk about the probability of an x assuming a value within a given interval, say between 30 and 60. You can talk about that, not just giving the exact value, but then a range of values. So that is what we mean by a continuous random variable. The probability distribution of such a continuous, you remember we did the discrete, and we looked at two kinds of discrete. We looked at the binomial and the Poisson. Now, the probability distribution of a continuous random variable is defined by the continuity associated with a cumulative density function. And so you write it like f of x, that is a probability density function, is equal to p into bracket x being less than the value. So in this case, you want a particular number of values that are below or equal to the specific particular value that you're looking for. And like all distribution, we always need to know the mean and the standard deviation. Do you remember? The mean is also known as the expected value. So what is the mean of this continuous random variable? Well, if the density function is f, then the mean is the integral of a negative infinity up to a positive infinity. And that is the value, the particular value, multiplied by the function. And so this formula that you see here becomes the expected value. And then the variance or the standard deviation. Of course, the standard deviation is the square root of the variance. The variance is given by this, which is just like the mean, but you are squaring the particular value and then subtracting the mean, okay, the square of the mean from it. Let's take a real life situation by looking at distributions, particularly normal distribution. And we are talking about height. These heights that you are seeing here are the heights of some female college students. As you can see, the heights are in inches. So if you look at the range, those with a height of 56 to 57 inches, the number of students were 3. And the relative frequency is 0.0009. Now, of course, you will know the relative frequency could be simply as the 3 divided by the total. And when you add all of the relative frequencies together, you should get a value of 1. So this is Midwestern College, which has an enrollment of 3264 female students. You can see the frequencies. First question, very simple question. What is a relative frequency that the student students are between 60 to 68. So go and check 60. Okay. So you go here, 60 is somewhere starting from here. So 60 all the way up to 68, you are going to find the relative frequency that a student is between that. And so you match this against the relative frequency. You take these values and you're going to add all of them together. So you take your calculator, you add 0.045 plus 0.0757 all the way up to 0.0 blah, 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 blah. When you do that, you are going to get a value something like this. Okay. You are going to get that range. And that will give you the relative frequency, which is 0.898. That's good. And why is that number big? It's almost like 89.8. Well, go and check the frequencies carefully. Okay. If you look at the frequencies, you will notice that some of them are quite big. You see, you have 15.7. You also have 17.1. You have 14.8. You have 11. So as you add these things, and then you have another 11. As you add these together, you're getting to 89%. Next question. What is the relative frequency that the students are shorter than 68? Now, you know that this is 68, so shorter than will be everything all the way up to this 68. So you now take the frequencies and then you check them. So you're going to add all of this. Remember, shorter than 68. You add them together. And then finally, what is the relative frequency that the students are taller than 68 inches? Now, clearly, taller than will be everything that is, remember, it says than 68. So 68 here will not be part of it. But anything rather from this section, let me see, this section, all the way down, you add them. That will give you the relative frequency. So you can have that. The second one, lesser than 68, that is its red shaded area. That will give you 93%, 0.9314. Now, taller than 68 inches will be the opposite of this. So the opposite will be 1 minus 0.9314. Okay. 1 minus 0.9314. And that will give you 0. That. So this is how you find relative frequency. They are more or less like probabilities that have been calculated. Okay. Now, taller than, okay, that's the one we asked. And the taller than is this, is just taking this value, which is the 1 minus what we had. You can also plot the distribution of this normal data. And you can see clearly that if I should take a normal curve and pass it through this, you will notice that, okay, you will notice that it looks quite what? Bell-shaped. It looks quite bell-shaped. So this is a normally distributed variable height in inches. The distribution is good, but please remember that one of the assignments, I've told you to not use the distribution of histogram or bar chart, but rather use the kernel density plot. The kernel density plot is a smooth histogram. It's beautiful. You want to look at that. Okay. Now, what then is the probability function? The probability function is that entire space, okay, of the bell shape, that entire space. So all the space, including the red line, that is the density function. That. And in fact, that's what we calculated. And we expect that the entire area will be 100%. The probability density function is different from the cumulative probability density function. The probability density function is of a particular variable. And then where you are looking at how far it is from some range of variables, or whether you want that exact particular variable. But a cumulative probability density function, which is given by this formula, is just the addition to the existing. You remember when we're doing the binomial, when we're adding them, when we're adding them, when we're adding them, and the Poisson, we're adding them as well. We're adding them. So you calculate the first one, you add the next one, you calculate the next one, you add the next one. And that was the cumulative probability density. For normal distribution, which is continuous, that is what it is. But let's get deeper into normal distribution, because when we say normal distribution, what does it mean? It's a probability distribution. It's a model. It tells you empirically the behavior of certain things. For example, what is the behavior of certain things in practice? We just saw that of height, age. There are several things, there are several practical things. Because it was actually discovered by a man known as Carl Friedrich Gauss. So that is why it's sometimes called a Gaussian distribution, the bell-shaped curve. Very practical. Income is normally distributed on average. Ages are normally distributed on average. The scores of students are normally distributed on average. The blood pressure of people is normally distributed. The volume of water is normally distributed. It's widely used. Very practical. Okay, very, very practical. Now, the interest is that you want to, the form or the shape of the normal distribution is what we showed earlier, is a normal bell-shaped curve. The key point is to find the area under the normal curve. I'll show you very soon, don't worry. The area under the probability density function. The area between a particular variable and another variable. And you can only do that if you use a standard normal distribution. Now, this is the standard normal distribution, and this is an exponential distribution. The standard normal distribution is bell-shaped, as you can see here. If I want to know the whole area, I know that the area is 100%, 1. But what if I want to know a portion of the area? If you want to know the portion of the area, that is like the green portion. Well, the only way you can know the portion of the area is to first of all know the middle half of the area. I'll give you an example, you'll appreciate it even more. If you cut the area into 2, half of it is 0.5, and the other half is also 0.5. The normal probability density function, the function itself is given by this, 1 over sigma, okay, which is a standard deviation, okay, square root of 2 times pi, the exponent of x minus x, which is a particular value, minus the population mean squared divided by 2 times the variance. This is that. Okay. And we know all of these terminologies. This is the standard normal distribution, and the mean is always the center of that graph. The standard deviation is always how spread the data is. Of course, we know the mode is at the top here of the hill or the peak. Now, these values, we have them systematically examined already in life. Last time, one of you said, how do we get a value? But these have been calculated already and divided into a table, and we know that the pi is 3.14157, and then the natural log is 2.718. You know this. Now, the x value is what you will be given and what you would have to find. Now, the probability density function is symmetric, as you can see, meaning that half is equal to half, meaning that when you're standing in front of it, you will see yourself in a perfect distance and area of it. It will always have a mean, a population mean, and a population standard deviation. The mean will control the location of the distribution, also called the center of the distribution. Then the standard deviation will control the spread or the scale of the distribution. The highest point is the mean, the median, the mode. So look at it. As you look at the distribution right now, if you want this distribution to be flatter, as it becomes flatter, it means that the standard deviation value, the sigma, is increasing or decreasing. As it's increasing, then this green thing becomes flatter or taller, depending on the value of it. But when this green shifts to the right or shift to the left, that is not caused by the sigma. It is caused by the mean. So when the mean value shifts, it actually shifts the distribution. When it changes, it shifts the distribution to the left or to the right. So when the mean increases, the whole green line will shift to the right. And when it falls, it shifts to the left or 0. Now, given the population mean and then the standard deviation or the variance, we can define the normal distribution using this notation. This notation is said to be the fact that X is distributed. The distributed is represented by the tilde sign. X is distributed normally with a mean of mu and a variance of sigma squared. Of course, that variance could be taken as the square root and you have the standard deviation. So for any normal random variable, X, that has a mean, that has a standard deviation, we can find the cumulative distribution. Remember, we can find the distribution anyway. So why not the cumulative distribution? We can find the cumulative distribution as this particular formula. So as you add a particular portion of the area together, you are creating the cumulative distribution. The probability of a range of values is measured by the area under the curve. And I've said it already, our goal is to find the area. Let me give you a couple of areas. So these are some areas. If you take this first one here, remember that the line in the middle is the mean. And please note this, when you enter the area, you enter into the middle. And so when you want to move, you move leftward when you're going to the left of the area, or you move rightward when you're going to the right of the area. When you enter, you always move right or you move left. Keep that in mind. And when you enter and you're moving right towards B, what it means is that in terms of probability, that portion is 50%. When you're moving towards the left, that portion is also 50%, 0.5. So you can see that the shaded area, we already know the left side because it's already 0.5. What is already left now to calculate is the distance of the area between the mu and the B. How do you find that? How do you find the area? Well, there is something that can help you find the area. But I just want you to know that. So when you're finally calculating this area, you have to first of all note that this portion is 0.5. And then calculate this little area. Let's say the little area is 0.1. Then you will now add the two together to say that the area is 69. So how do you find the second one? So just know that sometimes you know all of the area, but sometimes you don't, sometimes you know half of the area, like this first graph. But look at the second graph, you don't know half. You know that this very one is 0.5, but that is not where it is shaded. Remember, where it is shaded is where you focus on. And so you got to know that you would have to do the shading based on your understanding. You see, there are some key English words that guide you in knowing where to shade. So if you look at this area, I told you that we always move from the left. So in order to find this green-like area, you would have to know that the whole of this area is 0.5. So you got to read this distance, the white area, because when you're moving, you move past the white area before you get to the green area. So you got to know the area of the white. Then you will subtract that from 0.5, and that will give you the green area. So the green area will be equal to 0.5 minus whatever that other area, which is the probability, what other area is. So look at the way you write it. You write it as P, okay, being X less than A. Less than A because you're looking at the area lower than A. Remember, A can be 25 inches, 65 inches. And you want to know all those students who are below 65 inches. And then you have a very tricky one, where you want to rather find the area in the red zone here and the area in the blue zone here. Remember, when you enter the new area, when you enter the gate, you move leftward and rightward. The moment you move leftward, you will capture that red area. It's not like the green one above. The moment you move rightward, you will also capture the blue area immediately. So in this case, you don't have to subtract any of them from 0.5 because you capture the area quickly. And then you add the two together. And that will give you the probability. Remember, the word probability here is the area under the curve. Let's take another beautiful example that will help you capture all of these magnificent points that we are talking. If you want to find the area, which is the probability, you need to pass through a standard normal probability function. You got to use something called the standardized normal distribution, which is always between 0 and 1. So this is what I mean. You have a particular random variable, say x. X is, say, 65. And you want to find all the numbers that are greater than 65. So actually, you're looking for the probability that x is greater than 65. That means that you got to identify any point here, which is 65, and then you're looking for the area above. Okay? The word is above. By this time, you have been given the mean already, and you have been given the standard deviation already. How do you find the area above? It's very simple. You just need to know the equivalent z-value for the 65. Go and find the z-value for the 65. Because the z-value, all the numbers here has also gotten, as you can see, a corresponding z-value. Where the numbers going to the right are positive z-values, the numbers going to the left are negative z-values. If you know the value of z, okay, you can now use this formula here to find if you know the formula for z, you can now use this formula to find the actual z value. Because you know the mean and standard deviation, and you would have known the 65 is the random variable. Once you know that, you can find the z. Okay. So remember, you've been given the x. Use the x to find the z. Once you have the z, you can use the z to find the probability. An example will do. You agree with that? Let's take an example. Let's take an example. It will make everything that looks like Hebrew look really clear for you. Okay. Bogas are very good when it comes to furniture, carpets, living room chairs and tables and those things. Yeah. They sell these kind of carpets and furniture and all of that. From years, it is a case study, from years of sales records, management has found that the mean number of yards of a carpet demanded by customers during a week is normally distributed. Watch the word, is normally distributed. So that should know that it is a normal distribution you're looking at. And you're always given the mean and the standard deviation. So you're told that with a mean of 4,200 yards and a standard deviation of 1,400 yards. The moment you get these values, put it down. Okay, so now the store manager will now want to know the probability that if I should select a carpet at random, what is the probability that that carpet will exceed 6,000 yards? Now, the first thing you got to do is to draw the look of the distribution. Watch it. You got to know the mean. Okay, the mean is 4,200. The standard deviation is 1,400. And we are looking at not 6,000, but exceed 6,000. Let's learn how to draw it first. Okay, that will help you today. So what is a mean? Okay, we know that's the mean. I'll come back to the graph. Okay, we know that the mean is 4,200. The standard deviation is 4. So you go here. If you were to draw, you draw something like this. You show your normal distribution like that. You indicate the center, which is the mean. The mean is 4,200. So you write it there, 4,200. The standard deviation is 1,400. So you write it there, 1,400. Please always do this. If it is a mean, write the mean equal to, write the standard deviation equal to. Remember that the values on this x-axis are the x values, but they are also the z values we are about to convert. We have been told that there is a number which is 6,000. What you got to ask yourself is that 6,000, looking at the mean of 4,200, where do you think the 6,000 will be? Will it be to the right of the mean, or it will be to the left of the mean? Obviously, it will be to the right of the mean. Now that you know it will be to the right of the mean, just identify any right space like this and write 6,500 there. Now you ask yourself, we are looking for an area. The area can be A, it can be B, it can be C. Looking at the English upcoming week, what is the probability that demand for carpet is going to be exceeding 6,000 yards? Is that area A, B, or C? That's C. We're looking for the area here. Fantastic. So now we are looking for how do you write it? So you're going to say that you are looking for the probability that X is greater than 6,000. Sorry, 6,000, not 6,500, 6,000. Okay, that's what we are looking for. But it should also correspond to a z value, okay, probability of a z value being greater than some number. We don't know the number yet, we are going to find it. Because every random variable x has a corresponding z value. So now you've been able to draw and shade. Always draw and shade. You get good marks on that. How do you get that area? Remember that in order to get this area, you have to bypass the area B. So what you are going to find is not going to be the shaded area C, but it's going to be the shaded area B. So when you rather find that, you got to subtract that from 0.5. Because we don't want the B, we want the C. Subtract that from 0.5, and that will give you the C area. How do you do that? Well, let's check that. So first, get a standard normal formula. So this is a drawing. Formula is Z equals to mu minus, X minus mu equal over sigma. Okay. We know the X. The X was the 6,000, so we know it's 6,000 minus mu. Mu is 4,200. Divided by the standard deviation, that is 1,004. So you take your calculator and you solve for that. Can you do that? If you take your calculator and then you solve for that, what would that be? What do you think it will be? You got to, of course, be able to punch, dial, and solve some of these things by yourself. See, it's good that you solve this thing yourself instead of waiting for me to give you the answer. Okay. If you are waiting for me to give you the answer, it's not healthy. Solve it yourself. Okay. When you do that, you're going to get this value. Whatever value you get, you will notice that the value must be corrected to 2 decimal places. You are going to get 1.28 something. But then look at the next number and convert it. When you convert it, you're going to get 1.29. So you're going to get 1.29 standard deviation away from that of the mean. Your z value, ladies and gentlemen, your z value is 1.29. Now, what area do you think this is going to be? That 1.29, if we go, is a z value which will give us a probability. It will give us a probability here, this area here. So we got to go and read this from the z table. How do you do that? Let me go up here, and you all have the z table, so check your z table. Okay. So when you look at the z table, this is how you read it. 1.2. Pick this one on the far left. Okay, 1.2. So you can see that 1.2 is right here. Okay, you pick it on the far left. Then the 9, which is the next one, you take it on the top. Okay, so if it had been 1.21, you would have chosen this. 1.23, you would have chosen this. 1.26, you would have chosen this. But this is 1.29, so we choose this. So we have 1.2 and the 9. So go to 1.2, then start reading, okay, all the way under 9, and you will get 0.4015, this value, 0.4015. That is the value you are going to have. So I'm going to go here. So if you go and read, that will give you 0.4015, but that is not the value you're looking for. That gives you the area here, 0.4015. What you are looking for is this. So what do you do with that 0.4015? You subtract that from 0.5. Remember, the whole area on the right side here is 0.5. So how do you write your final answer? You say the probability that x is greater than 6,000 is the same as the probability that z is greater than 1.29, which is equal to 0.5 minus 0.401. Remember, we were supposed to subtract. And when you do that subtraction and your everything is correctly done, you will notice that you are going to get a value which is 0.0985. 0.0985. What does this mean? If you multiply this by 100, okay, it means that you're going to get 9.85%. What does that mean? It means that the probability, the chance, the likelihood that demand for carpet will exceed 6,000 yards next week, the chances are slim. The likelihood is very tiny. There is only a 9.8% chance that demand will exceed 5,000. Because when you say 5,000, it means that 6,000, sorry. When you say 6,000, 6,000 is even more than 1 million. 6,000 can include 1 million. So for you to say that demand will exceed that, because that's a possibility, that is a wild guess. And therefore, that is how you got to do your conclusion for this. Everything that we did is here. And how you write it all is clearly shown here. This is how you do the calculation. And then, of course, how you write the final result is that. Okay. Now let's go to the next one. The next one is, let's look at, let me just go up there. It says that what is the probability? I'm looking at question 2. What is the probability that demand for carpet will be 5,000 or less? So watch the words, 5,000 or less. Okay. How is it going to be shaded? So remember, it's the same mean you already have. Okay. The same mean. The same mean. If you have to draw, you have to draw. So when you draw, you're still going to get the 4,200. Always write the mu equal to 4,200. The sigma equals to 1,004. And this time we are looking at 5,000 or less. So ask yourself, 5,000, is it to the right of the mean, which is 4,200, or to the left? It's obviously to the right. Okay, so you just look for the space to the right. Okay. Let's say here, and just write 5,000, 5,000, correct. Now it says or less. So or less means all the area below 5,000. That's what you're looking for. But you already know that half of this area is 0.5. So all that we need to do is to find this little bit here, and then you will add it to the 0.5. That will give you the whole area. The z will help you to get it. Okay. The z will be equal to the x. What is the x here? The x is a 5,000 minus the mu. What is a mu? It's still 4,200 divided by the standard deviation, which is 1,004. So you take your calculator and then you solve for these values. What do you get when you do that? You're going to get 0.57. That's what you get. Okay. You get 0.57. Remember, always round it to 2 decimal places. So that's going to give you 0.57. So you go to your z table here, you go and read 0.5, 0.5. This is 0.5. This is 0.5. You got that. Excellent. You got that. Now, you have 0.5, and you're going to look for under 7. Look at the value, under 7. 0.5 under 7. That's what I'm looking for. So under 7 means that you have it here. This is under 6. So under 7 will be here. So if you take this one, you just go leftward until you get to that under 7. And that is 0.2157. 0.2157. Okay. So that is the value you're going to get. So when you go and read this area here, remember you stood in the center and moved to the right. So you read the thing correctly. It's 0.2157. So now you add that to the 0.5. That will give you 0.7157. So the way you write your final probability is probability that x is less than 5,000 is actually the same as the probability that z is less than 0.757, which is equal to 0.5 plus 0.2157. We are sure working, which will finally be 0.7157. So the chances that demand for carpet to be 5,000 or less next week, the chances are quite big because the average was 4,200. So the chances are going to be 71.5. Okay, 7. And that is how you would have calculated and concluded. When you draw, it's good. When you draw, it's good. When you draw, it's good. That's what you did here. So this is a drawing, and then this is your final answer, 0.7157. Good. Now we can go to the next one, okay? And when you check the next one, okay? In fact, let me just go back, but you should know that, okay? I'll pick it up from you so that you see what is happening. The next one says, what is the probability that demand is between 3,000 and 5,000? So 3,000 is below the mean, as you can see. So I noticed 3,000 down here. 5,000 is above the mean. So you also indicate that. We are looking for the area between the two. So that's why it's a shader. So you have to go to the center line, move to the right for the 5,000, find the area, go to the center line, move to the left, find the area, and you add the two areas. And that is your probability. How do you get a 5,000? Use the Z formula and get a 5,000. We already done that. And if you could remember, when we read that 5,000, using the Z, we got 0.757. And then when we read the 0.57, we got to this value. Okay. Now we have to do the 3,000. So when you substitute this 3,000, you're going to get negative 0.86. Okay. That's what, because we are moving to the left. So the z value will be negative. Now that you have that value, remember, you're only going to read the negative on the table. And this table is a mirror image. It's symmetric. And so whether it's negative or positive, you get the same area. When you go to the table and you go and read 0.8 under 6. That's what you read, 0.8 under 6. For purposes of you understanding what we are doing here, I'm going to just go to the table and show you. So what you do is this. Go to the table here. Oops. Okay. So this is the table. And then you read from the table, you are going to read 0.8. You are going to read 0.8 under 6. See how you read is very important. So this is 0.8, and then under 6, so you get 0.3051. That's it, 0.3051. So now let's go to our value. 0.3051 is the area. Okay. So you do 0.3051. That's it, 0.3051. You add it to the 0.2157. That will give you the range. Watch the way I wrote it. It's a range between 3,000 and 5,000 inclusive. So there's a 52% chance that demand for carpet will be within that range. That is how you calculate these probabilities. It's a very, very nice, excellent thing. Now you can do the same probability distribution in Excel. The distribution for the customer demand is normally distributed, and it has a mean of 750. So this is a rate, something I'm giving you. It has a mean of 750. It has a standard deviation of 100. How do you find this using Excel, the probability distribution? And you remember the last time I gave you some data in Excel. Okay, let me see if I can show you that data in Excel. And then it is that data, we have something for binomial, we have something for Poisson, and now we are going to have something for normal distribution. And then we are going to use the normal distribution, assuming that the mean is already, the population mean is already 750. Okay. And remember, the population mean is not the same as your, it's not the same as your mean. Okay. So I'm trying to show that. Let me stop here and then show the population mean. My Excel is opening. Just give me some time. The computer is slightly slow because I have too many documents opened. But hopefully the Excel should pop. But whilst that is happening, let me show you something. Okay. 65%. Okay. So now I think we are in. So let me show you. So let me click share, and I hope you can see my screen. All right. So I have just these numbers here. Okay. You have these numbers here, and I have the mean. Okay. It could be that mean or estimated mean. I have the mean here, which is 750. I have the standard deviation, just assume standard deviation. How do you calculate the normal distribution, the probability density function? Not a cumulative, but a probability density function for each one. How do you calculate that? Let me make it slightly bigger here so they can appreciate it. So how do you calculate that? Well, what you do is that you start from here, and then you use the formula called norm. So if you start from, let me assume that I'm doing here, okay? You will take the formula called norm, N-O-M. It will pop, norm distribution. You see norm dot dist. Okay. Then you will select the random variable, all of them. Okay. All of them, you select them like I've just done. Good. And then once you've selected them, you take the mean. Okay, so you do a comma. Oops. Hold on. Let me try again because it looks like. Okay. So, comma, and then you take the mean. This is a mean. Okay. And when it gets to the mean, you can do the F and F4 key because we'll be using that mean all through. In fact, you can even choose not to do anything like that. So you do a comma, then you select the standard deviation. You do a comma, then cumulative, you take false. You take false for cumulative because we just want to do not a cumulative, but then the probability density function. Okay, and after that, you click enter. Hold on, let me see what happened. Okay. So I'm just going to delete and start again. My system is not showing. All right. So let's start. Okay. You do this, you take this value. Oh, you type the norm dot distribution. You take all of these values, you do a comma, you take the mean, and then do F and F for P, because you're going to populate the result. You do a comma, take the standard deviation, do F and F for P, do a comma, and then you select the cumulative distribution doing false, and you click enter. Okay, so that's it. Once you click enter, you come to the bottom right, you double click, and you get all of these results. Okay. Now, what you are seeing here is a normal distribution. So you get the normal distribution for each variable. So that is a fx, which you have here. To get the cumulative, which is the next one here, all you got to do is just do the same thing when it comes to the cumulative. You take true instead of false. That's all. So equal to normal. You select this. You go and select all the data sets. Okay. Done. You bring your commas, take the mean, do F and F4, okay, comma, do the standard deviation, which is 100. Do F and F4, comma, then cumulative, this time you do true, and enter. And that you can see, if you run these cumulative numbers to 2 decimal places, if you go to decimals and reduce the decimals, and okay, take all of these, they just reduce the decimals. As you can see, the closer you are getting to 1 for the last one. Okay, so you can see that the last ones are 1 because we are adding all probabilities. That's what you do. You can also draw the cumulative density function, which is here. Okay. The cumulative density function, you can just draw. So you can highlight this one here, go to insert, and in fact, you can even choose recommended. Okay. And the recommended, you will get some of the recommended ones. But if you don't, yeah, the one I'm looking for is you can just go to here and choose a cumulative density for that. Okay, but that's not what I'm looking for. So let's go back. You do insert. You can do that. But it looks like I'm not doing the cumulative density. I was doing the random variable. This is the one you select. Good. This is the one you select, and then you do the cumulative density. So go to insert, choose this. In fact, this time recommended will give you the better because I was doing this is it. You can select this one or this one, anyone. That will give you the cumulative density function. You do OK here, you will have this graph of a cumulative density function, which is cool. Okay. This is a graph of cumulative density function for that. If you want to find the probability density function, not a cumulative, you just select these ones. Okay. You go to insert, and then you will see the probability density function. And you see that it looks clearly like normally distributed. Just watch, there you go. It is really normally distributed. This is sort of it looks like a kernel density, but it's not smooth. In fact, I think there was a smooth one that you can use. Let me see. As you go through this quick layout, you might get the smooth one. Well, some of them looks cool. Some of them don't look cool. But if you go back here and you choose recommended, one of them was quite smooth. Even that is not that smooth. Okay, but that is the closest you can get for kernel density plot. Anyway, so this is how you do your plots. Come, let me go back to the slide. So we're going to go back to our slide. Let me come back. So that is the distribution. Everything that you see here is what I showed you here. And on the basis, you can calculate something. For example, if I tell you to find the probability, okay, find the probability, just a second. Just a second. All right. So find the probability that demand will be at most 900. Okay, at most 900. What it means is that you're going to change the value here to be 900. That's what it means. Okay. Find the probability that demand will be this. You can just between this and that, you change this. So those ones, those are the values you see I put here. Okay. Demand for that to be 900, just go to at most up to the 900 value, and you see that. You can even see it from here. Okay, 900. If you match it here and you look on the left, you will get to the probability. Between exceed 700, you see it. At most 900 is a cumulative one. Exceed 700 is also cumulative. 700 to 900, you use a bit of a cumulative between the two. So that is how you can use to find the result. But let's go to the latter part of. So we have learned how to find P moving from X. Okay, let me just remind you of something interesting. So once you know the value of the X, you can use that value of the X to find P, but first you need to find Z. And once you find Z, you read the Z from the table, you find the probability, which is the area. We are going to move the other way around. Okay, we're going to move the other way around where the probability is rather given to you. And it's just a matter of using the Z value to rewind. Because if I don't know the probability, if I know the probability, okay, but I don't know the X, but I know the Z formula, okay, the Z formula is Z equals to X minus mu over sigma. So I can make X the subject. And when you make X the subject, you get this one. It's very simple. Cross multiply, then rearrange. Okay, keep that in mind. Once I know X, all I have to do is that to find this X value, if I make X the subject, it means that to find this X, I just need to, because the mean has been given, the standard deviation has been given, I just need to know this Z value. Once I know this Z value, I can now go and read the Z value. Once I get the Z value, I can substitute it here together. But then you've not been given the Z value. What you've rather been given is a probability. But remember, we normally look at the Z from the far left and the top to find the probability. So if I know the probability, I can look at the far left and the top and I'll get my Z. Isn't that beautiful? Should I repeat that? If I know my probability, which is in the swimming pool of the table, I can read the corresponding Z on the left and then the other part of the Z on the top. I can now, if it is 1.6, I can say 1.67, and then I can substitute that here for the Z. And then with the mu and the standard deviation, I can find my X. I just need to know whether I'm going left toward or right toward. I think an example will do. Let's take an example. Suppose that the price of wache is normally distributed with a mean price of 8. So you know the mean, the standard deviation is 5 Cs. Find the price. You see, now it's asking you to find the price, that's X. Find the price of wache so that 20% of all wache prices are below this price. 20% of all wache prices are below. Below is very important. And you even have to draw. How do you draw? Well, get a sense of it first, and then the drawing will be cool. This is what I mean. Let's draw it. Let's draw it here. So you have the normal distribution. You've been told that the mean of wache is what? Is 8 CD. The standard deviation is 5. You put it there. Now, find the price of wache. So I'm looking for an X value because the price of wache should be either above the 8 CD price or below the 8 CD price. I don't know where it is, but the clue is that it is in such a way that 20% of all prices, of all wache prices, are below this price. So if I take any price here, okay, let's assume that I'm taking any price here. It might be here, it might be here, it might be here, it might be here, it might be here. The price is in such a way that 20% of all wache prices are below this. Now, what is 20% of this graph? Remember that the entire graph here going rightward is 100%. So when you move from here to the center, how many percent is that? That is 50%. So from here to the center is 50%. Which means that from here past the center to somewhere here will be about 50%, say 60%, 65%, 70%, 80%. You just don't know. So now he's talking about 20%. So why do you think 20%, given that the whole area from left to right is 100, where do you think 20% will be? Is it 20% going to be on the right or on the left? Obviously on the left, because 50% is from the left to the center. So 20% will be from the left here to somewhere here. So we are talking about 20% here. Okay, so now I know that 20% is from left to this side. So I can say that up to here is 20%. So if that is 20%, what do you think is left here? If from here to here is 20%, what do you think is left there? That is 30%, which is 0.3. So the area that we are looking for, which have been given to us, is the 0.2. The 0.2, which is the 20%, has been given to us. Okay, now we are looking for below that. So below that, is it the 20% we are looking for, is the 30%, or 30 plus the 50% on the right? It says that all prices are below this price. So this one here. Okay, so we need to find this value here. This value at that junction. How do you find the value? Remember that normally when we are looking for an area, which now we have been given already, which is a 20%. Normally, when we are looking for an area, we move from left to right. Do you remember? We stand in the center and move from left to right. Sorry, we move from the center to the left or from the center to the right. So normally we would have moved that 30% to here to give us this X value, which right now we don't know. So what we are going to do is, even though we've been given the 20%, because what we are looking for is below 20%, we have to start the movement from the center to that point. So that means that we have to read 30%. So 30% is what we got to go and search for in the table. Ladies and gentlemen, how do you find this 30% in the table? What I'm going to do is I'm going to go to the table, and then I will show you the table and show you how to find this 30%. Good. So let's look at the table. So when you look at this table, oops, I hope you can see it. When you look at this table now, you will see that the spaces here are big, right? You have 30% is actually 0.3. Keep that in mind. Okay, 30% is 0.3. And here we have 0.1, 1950, 1950, that, 0.2. Now we got into 0.2, 0.2. Now we got into 0.3. So we've got to go back. We are looking for 0.30. Okay? 0.30. This is 0.305. This is 0.302. This is 0.299. Good. So now we are between 0.2995 and 0.3023. Which one is exactly closest to 0.3? Well, if you have a mathematical eye, or if you are confused, just subtract both of them from 0.3. And the one that gives you smallest absolute value, that one is the closest. When you do that, you see that the 0.2995 is closer to 0.3 than the 0.3023. Therefore, our 0.3 is what you see here. Now we need to find the corresponding z value. So to find the z value for this, you move leftward, okay, until you get here. That is 0.8. Now move rightward, topward. Okay, move topward, that is 0.4. And remember the graph you drew, that 20% graph. Where was it? Was it to the left of the center, or it was to the right of the center? Was it to the left of the center or to the right of it? It was to the left. If you can remember, the 20% was to the left. Even the 30, we were still going leftward. Therefore, the z value will have to be negative. So even though the z value is 0.84, you got to give it a negative value. And now that you know it's a negative value, let's substitute it into the z formula. Remember, the z formula is z equals to x minus mu over sigma. We know the value of z. It is now negative 0.84. We don't know the x. That's what we're looking for. But we know the mean. The mean is 8. The standard deviation is 5. So now you can just cross multiply and find x. The rest is history. The rest is enjoyment. Okay? The rest is basically what is known as equation. So let me show you how it's done. You see, these things are cool. If you are taking your time, you are going through it, you're repeating it a little, you will get it. Once you get it, everything that I have showed you is here. Everything that I wanted to show you has been drawn here. So this was a one we're looking for. Okay? And then you find everything that I said is here actually. So you find the price. So now we are going to get, I've shown you how I took the 0.3 instead of the 20%. I took the 30%. And now you go and substitute this, everything. The reason why it was negative, I explained it here as well. So check it. Because it's on the direction to the left of the mean. And so now we substitute this, we calculate that, and then the x value is 3.8. And go and check. You see that 3.8 is truly below the mean of 8. So the price, okay, at where all prices are 20% below the price, okay, the price, okay, so what it means is that 20% of all the prices are below this 3.8 cedis. 20% of the prices are below, which means that 80% of the prices are above this 3.8. Of course, the mean price is 8. Now, the word was 20% of all the prices. If it has been, find a price where 60% of the prices are below. So in this case, you draw the thing, bypass the mean. Okay, suppose the question has been where 60% of the prices are below. Okay, in this case, you will just go here and then identify 60%. Remember, 60% is here. So you're going to look for all the prices here. So that means that you need a price here. This is a price you're looking for. And if this thing is 60%, it means that the gap here is what? If the whole of this is 60%, if the whole of this is 60%, then it means this gap here is 10%. It's 0.1. It means that this one is just 0.1, 10%. And so 10% is what you're going to read. Remember, when you read, it's on the right side, so to be positive. So you read the 10%, get its z value, and substitute it into the z formula and find it. And that price is all you are looking for. So that price, obviously, the price is going to be more than the mean of 8 cedis. And that price will be the price where 60% of prices are below. That is how you solve it. But if I should say that, give me a price where 90%, okay, give me a price where the top 10% of prices are relevant. Give me a price where the top 10% of prices are relevant. Top 10 is here. The rest is 40%. So even though he's talking about the top 10, okay, which is 10%, you can't get to that 10% unless you bypass the 40% because you always read from the center. So you got to now go and read a 0.4. And then now 0.4 probability, dump it into the swimming pool and search for the number closest to the 0.4. And then match it with the z value left and top. And once you get that z value, substitute that z value into the z formula. And then you find your x. It's beautiful. It's sweet, isn't it? It is like yogurt. That is how you find all of this. If you follow and go through it, you can create even your own questions related to this. You can find it. Now, a situation where you can do this is also given you. Okay. For example, here, how to find the x value. Okay. Once you have the probability, as you can see in the red, and you have the mean and the standard deviation, you can find the corresponding x value. For example, what level of demand will be exceeded at most 10% of the time. Remember, at most 10% of the time. So you're finding X in such that you're looking for the 60%, 90%. 90%, you can't find 0.9 from the table I gave you. What you got to do now is to put the 5.5 away and deal with the 0.4. And then you go and do that. But if you want to put it directly into the formula, then that one you can get this. So if you put this one into the formula and do normal.inv, remember the inv is going to give you the exact probability value. Okay. And this is cumulative because it says at most 10. At most 10 is 0 up to 90%. That is why you have 0.9. And that will give you this value of 870. So you can put this and run that in the question. This is how you draw it. And you can use that Excel function norm.s.distribution to find probability for the standard normal one. Okay, the standard normal one there. There is also an exponential distribution. I'm not going to go deep into exponential distribution, but just understand some basic principles of exponential distribution. It's very useful if you want to describe the time it takes to complete a task. For example, the time it takes between vehicles arriving at a toll booth. How long does it take? This is very good when you're doing queuing models. How long does it take to wait before you get to the toll booth? Which means there's a queue building up. The time needed to complete a questionnaire. Okay. If it's taking long, you will know. If it's taking short, you know. The distance between major defects in the highway. Okay. Suppose there's a defect. How long does it take to meander your way after? These are all exponentially distributed. So these are multiple examples of exponential distribution. The time between trucks arriving at an unloading dock. The time between transactions as an ATM machine. How long do you wait today? The time between the phone calls to the main operator. You can have an exponential distribution, and you can even have its cumulative probability distribution. You can have the probability density function and the cumulative probability distribution. But the question will tell you whether this is an exponential distribution or not. Customers arrive at the service counter at a rate of 15 per hour. See, per hour has been given. An hour is 60 minutes, which means that half an hour is 30 minutes. Customers arrive at the counter at a rate of 15 customers per hour. 15 customers per hour means how many customers per 30 minutes? Okay, don't worry whether you get a decimals or not. Question is, what is the probability that the arrival time between consecutive customers is less than 3 minutes? See the word, less than 3 minutes. It didn't say it's 3, less than 3 minutes. This is an exponential distribution because you have been given an interval of time. Now, sometimes the temptation is that you might think that this is Poisson, but it's not, because you are dealing with decimals here. If you look at the time is a continuous variable. Okay, so first thing you got to do is to identify the lambda, which is the mean, the lambda. Okay, and then the lambda here is 15 customers per hour. Okay, 15 customers per hour. But the question was actually in minutes. But this one was in hours. So you got to change this one to minutes. So that is 60 minutes, 15 hours, sorry, 15 hours, 15 customers per hour. So 15 customers per hour. And now we are dealing with 3 minutes. So how many customers do you think you can have for 3 minutes? If you have 15 customers per hour. So now you have 3 minutes. How many hours would that be? 3 minutes. Whew. 3 minutes in an hour. That's quite strange. That will be 0.05 hours. You check. Okay, all you got to do is take that 3 and divide by 60. and that is 0.05. So you get 3.05 hours. Okay, now you've been able to convert the minutes now to hours because this one was already in hours. Then you bring into the formula. The formula is 1 minus the exponent of negative lambda. The lambda is 15. Okay, and x is the 0.05. You substitute that into this formula, and you are going to get 52.76. The probability that the arrival time between the consecutive customers is less than 3 minutes is 52. So the chances are that between 3 customers, before a customer is served, we are going to, the probability that there will be 3 minutes between this customer and that customer is going to be just 53%, which is quite slim, almost half. Which means that customers are actually waiting, probably more than 3 minutes. But for this one, we have that. So this is a typical quick example of exponential distribution. There is a 52% probability that the arrival time between successive customers is less. Every distribution we've done has been summarized here. The column on the left is the distribution. Then the parameters that will give you the clue of what you are to find. Okay? The ones that will be given to you, okay, is in the parameters. Then the sort of questions you can get to be able to solve is also here. And I've given you the Python statement, the Python commands you will need to calculate each one of these probability distributions. Practice them, work on them. You will get an assignment on them for you to use them. Enjoy the moment of learning. Remember that knowledge is the only asset that multiplies all other assets. Okay. We've been able to examine continuous probability distribution. We've shown the cumulative probability distributions. We've looked at normal and a bit of exponential. We found probabilities using formula and table. We've interpreted the normal probability plots. We've examined when to apply these probabilities. Go tell the world that we still have a better way. We've learned wonderful things. If there's anything, traffic it. Let me know. We will address them. Ladies and gentlemen, it's been a pleasure having you. Just let me know if you have any questions and we will address them at any point in time.